Okay, let me try my new game. Okay, what? I need about 4 hands for this. I can't do it alone. This is impossible, just impossible.
Hi, Grandpa.
Hi, good morning, Sarah. How you doing? What's up?
I'm very good.
Oh, well, that's in your hand.
They're fairy lights. The ones we used for my last birthday. When I hung them up and plugged it, it didn't work, and Mom said that we won't be able to use them again, and I don't know why.
Well, let me put it over there. Maybe I'll be using them in one of my inventions or something.
Grandpa, who invented the light bulb?
He was one of the greatest inventors. Just like myself, he was an American inventor called Thomas Edison.
How did he invent it?
I'll tell you. Go grab that bulb from the shelf.
Okay.
Learning time.
Here you go, Grandpa.
After many trials, Thomas Edison discovered that there are particular materials that are great conductors of electricity. They allow electricity to pass through them. Look here. If we look at this bulb, there are 2 bits of metal lead here. These carry the electricity from outside the bulb to the inside of the bulb. After the lead that is outside the bulb, you will find, look, hold this please. You will find, I will use this just to explain it to you.
Okay.
After the lead comes the little 2 pieces, look here, those are made out of copper. Okay, the copper is also conductor of electricity. This wire is made out of tungsten. This tungsten wire
Yes,
is
I can
very
see
thin,
it.
and this type of metal glows when the electricity reaches it. And it is a great choice because this particular material doesn't get too hot. All of them together are the electrical circuit.
Circuit like a circle?
Yes, the electrical circuit is kind of like a circle. The electricity travels through the lead to the copper pieces, and then it passes through the tungsten and makes the tungsten filament glow. Thomas Edison, the inventor, puts this electrical circuit inside a glass bowl to protect it and called it halogen light bulb. Do you want to see how it works?
Yeah.
Look. Are you ready?
Yes.
There.
It's much brighter than the light in our kitchen.
Yes.
Is it a different kind?
Yes, there's another kind of light called the fluorescent light. I think I have one here. I was planning to use it. Could you please grab that one
This?
over there? Yeah, the one on the left. The long white one. Be careful.
Here you go.
Look, Sarah, this is a different kind of light called the fluorescent light.
Why is this light different? Is it made the same way?
No, it's completely different. The first one has only one input, but the fluorescent light has 2 ends. Each has tungsten filament inside. Those ends were to be connected to the power source, and this tube is to be filled with an inert gas called argon and small amount of mercury.
That's the silver you have at the bottom of the thermometer, right, Grandpa?
Exactly. When we turn the light on, those 2 ends of tungsten start to be heated a little. Argon and mercury start to react to the heat and produce light. This glass tube is coated from inside with phosphoric powder, which produces the bright, white, wonderful light we see.
Wait. What about my fairy lights? What kind are they?
They are halogen lights, but on a very tiny scale.
Why aren't they working though?
Maybe one of them is burnt out.
No, they weren't near any flames.
No, that's not what I meant. It means that something happened to the tungsten filament. That's why it didn't glow.
If one bulb got burnt, why aren't the rest working?
Help me out first, and I will explain it to you.
More inventions, Grandpa?
No, not an invention. This time it's just a game. Put your lights over there and let's start.
Okay.
Go on. Let's start our game. Here's my car, and this is yours. Hold the remote. Now we are ready to start our challenging game.
This track is too tight. They'll have to follow each other. It can't be a race.
Come on, Sarah, just give it a try.
Okay.
Come on.
What?
Wait a second.
Your car broke down. Now I can't move mine till you move your car.
Now what?
Let's make another track and each car will go on a separate track.
Why not? Let's try.
Let's put this here.
This will be your track?
Yes.
And this will be mine. Each one has his own track. Let's go. Oh. Here we go. That's good. Now, they are not blocking each other's way. This shows us the difference between the types of electrical currents, whether parallel or series.
What do you mean, Grandpa?
Okay, when we had one track, one car was blocking the other. If one stops, the other will stop as well, exactly like your fairy lights.
Oh, so you mean my lights are connected on one wire?
That's right, because both of them were on the same track, on the same wire. The parallel current was when we were playing on two tracks. Each car was moving separately on its track as if they were connected to parallel circuits, which means if one of them broke down, it won't block the other. The cars here were connected to different currents.
So, next time when I go to buy new lights, I'll ask if they have series or parallel current.
Well done! You're a clever girl.
Today we learned about electric light bulbs. Electric lights work with heat and gases. Halogen light bulbs work thanks to a circuit of electricity. Tungsten filaments find copper wires and lead in the base of the bulb because all three metals are excellent conductors of electricity. Fluorescent lights work thanks to a reaction between the heat from tungsten filament at each end of the tube reacting with argon gas and mercury to produce light, which is improved by the phosphoric coating of the tube. And we learned about electrical circuits. When circuits are connected in a series, they stop if any of the components stop working. When circuits are connected in parallel, they can still work if any of the components stop working. I'll go ask Mom if we can go to the store to get new lights before the party starts. Goodbye, Grandpa. Don't be late.
Bye, Sarah.